IP implementations with 2110 are out there. They're installed, they're up and running, they're working. Maybe some people are still trying to figure out how to support and stuff, but hey, it's going, it's working. It went pretty faster than SDI used to go, let's say 36 years ago. So this is a pretty decent ride so far. But let's talk about a little bit the history, how we went through the whole story to get to IP. And we're going to talk about pets, cattle, and a few other strange animals. And this is where I hand over to Yevgen because he knows how to treat pets and that sort of stuff. So, yeah, it's inappropriate, I know. Talk to HR about it, please. So, a little bit about the timeline, and I'll start in 2015. Maybe there was something before, but why do I start in 2015? Well, maybe here on the top you see it. There's the reference architecture. That's a document that was written by the Joint Task Force on Networked Media. That's a mouthful, but that's the AMWA, the Advanced Media Workflow Association. There's VSF, the Video Services Forum. There's SMPTE, and there's EBU. Those four organizations are the Joint Task Force, and they put a task force together to create the first reference architecture, which upon everything actually is based. It's free to download, so if you haven't read it, please do, and a lot of the concepts that are still used today will be very clear to you. So 2015, JTNM reference architecture, and I won't bore you with all the details. In 2016, we saw the roadmap of networked media open interoperability. Now, let's move on. 2017, 2018. 2017, it was actually IBC 2017, I believe maybe the second day that they said, hey, 2110, it's published. Meaning the video part, -20, there was -40, and -30, not to forget the audio, were published. So off we go, we had our standard. That's fantastic. And at the same moment in time, and this is why EBU is very interested in this topic, a lot of our broadcasters are building new buildings. In Europe, they have built them in the 60s, meaning all those buildings are, well, falling apart. If you ever visit Brussels and VRT, don't come too close to the wall because they have these nice decorative elements and they have the tendency to fall off. So please step back a little bit. We're building a new facility and many of our members have done the same, but at the moment you're building, you're asking yourself the question, what should we do? Should we go SDI or should we already go IP? And many of those even had to make the decision before 2015. So that's quite a tricky thing to do. This is why EBU thought, let's do something about this. Let's dive in. What are the details? Because if we can lower the risk for all these huge projects, then we're in a good spot with EBU. So voila, you see BBC Wales Cardiff, they started the Central Square project. They already got the keys to the building at that moment in time. So you see the difficulties of, of those project leads. The roadmap, it's an evolutionary thing that you see here, small, handy, on the right-hand side. It used to be very big on the IBC and the NAB site as well at the IP showcases. It was printed in big. Now we changed it each time. We knew more and we put more details on the map. In 2019, I should say we did improve the maturity of the solution because things were going fast. Customers were buying stuff, but we needed to be sure that everything which came on the market was okay. So we started with a program, the IP showcase, and then we started the first JTNM tested program. We tested a zillion devices, and it was a lot of work. And you find those reports still online with all the ways how to test it and all the test results for free to download. No stress, you get it. Meanwhile, of course, BBC Wales was on air with the first studio. There we have CBC in Montreal, also on air, by the way, during COVID. So that's pretty a difficult time zone in order to work there, right? Now, moving to 21 and 2022, you see, we still had COVID. The force really stopped a little bit. You see new documents, but I cannot report more on new buildings in 2021. 2022, well, still improvement of solutions, but also a new version of EBU list, and Montreal went fully on air. Now, I should say in, let's say this year, where are we going to go next? Are we done? We're probably done. We're IP right now. There was a new tech document, we revised the pyramid. It feels like we're revising just the things that are out there. And then we thought maybe let's sit together with a group of EBU members, but also the industry, people from big graphic companies like NVIDIA, but also Red Hat, and a few members. And let's say, are we there yet? We're talking about IP, but is it okay what we have today, or do we need to take the next step? Now, of course, we need to take the next step. But I should say we are IT right now because everything in the backend is IP. There are IT servers, there's off-the-shelf servers. So, Yevgen, my bold statement would be we are IT right now.
Bold statement, right? Is it okay if I remain seated like this? Is it fine? Is it not too awkward? Yeah. Okay. So, who's already regretting getting on this boat? Okay. Good start. So, how many times have you personally heard a statement from a broadcaster or from a manufacturer saying, "We are IT now"? Some of you heard, yeah. Okay, so are we IT now? I would like to challenge a little bit this statement that we make from both sides of the field, from both the manufacturer and supplier side, but also from the broadcaster side, who says we're gonna be adopting the IT best practices, and we're gonna be scalable, we're gonna be flexible, we're gonna be agile. I'm gonna talk about the alternative history, so something that happened behind the scenes while we were trying to figure out how do we do IP, how IT industry was figuring out how they're gonna do their things, and way before I was born, way before my conscious days, there were mainframes, right? So there were huge computers. I guess someone here on the boat have interacted with mainframe computers, like the first Sun Solaris systems that were purpose built, that highly integrated with a dedicated operating system. And eventually, it became too cumbersome to have a freaking wardrobe of a computer for one application. And so also the compute resources that those computers were able to offer started to grow. And we thought, okay, it's a waste of space, it's a waste of compute for just one database. So what we did, we went into virtualization. We decided, okay, now my server can support more than a domain controller. I can actually run a domain controller, and on the side, I can also run my database. And so, thus, we started to disaggregate the infrastructure from the software from the perspective of the operating systems. So we introduced our Unix systems, our Linux systems, our BSD systems, and we said that, okay, this operating system is now, it doesn't care now what hardware it runs on, right? So the hardware can be agnostic and the software can be agnostic. And then we went a step further into virtualization. The next evolution obviously was containerization. We said, why do I need to deploy a full-blown operating system, a full-blown layer of virtualized hardware for just one application that runs arguably most of the time on a similar stack using the similar kernel system, right? And thus we introduced the lightweight containers, and we started to disaggregate even more software from hardware, but also now we started to disaggregate and decouple software itself, right? So we started to think about microservices. It's a very popular word now to say. And in an IT world, as most of you would know, the concept is that, for example, if you have a web application, the front end is a separate container, the back end is a separate container, and then there could be a container for data processing, for database, something like that, and they will exchange information. This also influenced how we design IT infrastructures now, because the data centers today are built on a completely different principles than the data centers back in the 80s. So we have pools of agnostic compute resources that don't care what you run on them, and also they don't have any intelligence or notion about what actually runs on them, and that is delegated to a higher logic. Same goes for the storage plane. It's just a pool of resources. And same goes for networking. We fundamentally changed how we design data center networks because the traffic patterns completely changed. We are not going to the internet, from the application to the internet and back. No, most of the traffic right now happens between the different parts of the application. So usually it's called north-south traffic when you go into the data center and from the data center, But now the request comes into the data center and it goes across, so east-west traffic, right? So we went into our spine leaf topologies. And the more we've done that, the more we started to abstract the actual resources from the logic of how they should run. We started introducing software-defined networks. We started introducing Kubernetes for managing resources, for orchestrating those containers. And also all these technologies enabled hyperscale cloud applications, right? So when you have those disaggregated containers that don't care where they run, they can run on any hardware. It can be a virtualized hardware, it can be on-premise hardware, it can be a hardware in the cloud. And because the applications are now very loosely coupled, you can scale them seamlessly. And if something fails, you just replace it. So all this was only available through disaggregation. I went already over that, but the most important principle that for some reason nobody in our in industry has heard about, and by the way, who knows the principle of pets versus cattle? Okay. Anyone? Anyone else? Good. No, it's okay. It's okay. It's not interactive. I'm going to explain. What is a pets versus cattle principle? So, does anyone have a pet? Okay, I have 2 cats and a snake. Some people have a. What happens when your pet gets sick? You take it to a vet, right? Unless it's a praying mantis, then. Okay. Sorry. You take it to a vet, you take care of it. Usually your pet should have a name, right? And you treat it as a part of your family, so it's important for you. And you nurture it back to health when something happens. You take care of it, you develop a custom diet for it, a custom care routine. On the other hand, there's cattle. And cattle usually has numbers, not names. Some farms are friendlier than others, and I understand that it can be a little bit of a gruesome concept that I'm explaining here, but if something happens with your cattle and one of them gets sick, most of the time you just move on with your life and replace it with another unit. And by the way, this principle can be applicable for IT, but okay. The thing is, in the data centers, we are not anymore nurturing individual pets. So in any hyperscaler grades, or even a normal data center that would be running a colocation or hosting or internet exchange or any other sorts of applications, the scale and the sheer size and the number of pieces of equipment in that data center would not allow you physically to manage every single device individually like an individual special unit, right? So they become cattle. They are deployed through automation. They are repeatable. If something happens to a switch, you don't go there with a console cable and troubleshoot that switch. You rip that switch out, you put in another one, and automation kicks in, zero-touch provisioning kicks in, and it deploys the configuration. Same goes for a server. When the server fails, you rip it out, you take care of it later. You put in another one because the operation needs to keep going. And same goes for the container. If a container fails, the Kubernetes cluster will not troubleshoot and will not let you troubleshoot. It will just kill a container and spin up another one. And it doesn't care why it failed, because of the underlying storage failure, because of the underlying compute node failure. It doesn't care. It will spin up another container using another resource available from the pool. Yeah, so in our perspective, we should reapply this thinking into media. And by the way, this principle is applicable to your equipment and really should not be applied to your technical stuff. Okay, so take care of your people. All this combined, these principles, right? The introduction of hyperscaling, the culture of a public cloud allowed us to consider a public cloud at some point to be suitable for media applications. And especially this, when COVID hit, the clouds, and COVID is messed up there because COVID is messed up. I'm sorry for that. Um, the cloud technologies, the adoption of the cloud for media exploded since COVID, right? So every single company suddenly became cloud native, cloud ready. They had cloud offerings, they had cloud solutions, either SaaS or lift and shift. Some of them were better than the others. And a lot of media companies adopted cloud very rapidly, very unexpectedly. And then people joked about what was the driver of a digital transformation in your organization. Yeah, like what C word? Was it a CTO or CEO? No, it was COVID. Um, so people started moving there as business continuity, but also they thought, okay, finally we can change the way we design system, change the way we approach procurement, and take capex versus opex, all this never-ending conversations. But then eventually, the reality kicked in, right? And in 2023 or earlier in 2022, those companies started getting AWS bills. And the rude awakening happened. And they realized that my Vision Mixer running in a public cloud on the on-demand GPU-backed instance may not be as cost effective because it runs 24/7 and billed by a minute, okay? And maybe some applications are better suited for cloud than others. Some operations should not be moved to cloud. They should stay on premise because capital investments still have their place. But on the same at the same time, we became spoiled and addicted to cloud thinking because cloud is awesome, right? You can scale, you can do redundant stuff, you can have elasticity, and we started asking, why cannot we have that on-prem? I think this is the time where I would hand over to Willem to talk about some other considerations.
Okay, let's try. So there's also business challenges, the budget, right? Who has a raising budget for their facility? I don't see many hands raised. Okay. Now, there's a big change, right? The broadcaster did own even the transmitter back in the days. That's not a fact anymore. So we need to hand off our signal. And on the other hand, we need to be where the public is. And that's at YouTube, that's TikTok. There's all those spaces on the internet. So immediately you feel a broadcaster has many, many more outlets to serve. And it's even another way because you put your signal in the air, it's gone and it's for free. But if you need to stream your services, you need to pay the man in the middle. That's for sure. So all of these things on the output change. And that's what many people have talked about, digital shift. That's right. But I think there's a digital shift in production as well. And it's needed because of, well, the outside does change, the way how to connect to our public does change, meaning a lot of money is shifting into that part. There's less available for the production part. So we need to be smart about how to produce and how to use that technology in order to make things work. And this is why we started to think, can we combine the concepts of, yep, we're moving to IP, and there's the IT world, can we do stuff that actually will help us a little bit? And then moving back from EBU to VRT and running the technical side of operations, you see technical rooms like this. And comparing pets and cattle, well, these are our pets. And it's even for a dedicated box that we have a support guy. And the support guy only knows this, for instance, orange box. And there's another guy that only knows the box with the panels here. And there's a huge complexity and a waste of money, if I look at it, that's being spent in all these dedicated boxes. So if we can move from those dedicated boxes into cattle, then we would be more efficient. So voila, that's the other way, right? If we look at the data center of, let's say, Google, this is what you see. And there's probably one guy running around to change something. If there's something broken, it just plugs in a new server and that's it. It plugs the back and the provisioning will do the rest. No stress. If this happens in the previous picture, there's a lot of people involved, I can assure you. So we thought about, well, if we bring this concept to broadcast, what's the change here? Well, the network, that's compute. Sorry, that's IT. There's compute, that's IT. There's provisioning, that's probably IT as well. But then there are the things that we do care about, of course. You need maybe a vision switcher, or you need other fancy stuff that's typical a media function. So this can be applied or deployed on a standard IT system. Of course, there needs to be control in between and something that we really see as a separation, and it's the colleagues from RTBF, that's the French-speaking broadcaster in Belgium, sorry, mouthful, but they said, well, you need to split the UI as well. Otherwise, you cannot scale up your production or you cannot scale it down. I'll try to explain. If you have a standard gallery, you know, the big vision switcher, and you have the position where you do the shading and that sort of things. If you want to do a production, all those seats, there needs to be a human body sitting on the seat because of the size of the gallery. Now, if it's a small production and you can squeeze those UIs into a smaller portion, then maybe you can run a production maybe with one or two guys. And if we can use this concept for big galleries, big shows, or even for small, then we're probably at the point that we should be. And that's something that RTBF will be building in their new building, by the way. So how should it look like? Well, if we zoom in a little bit, actually the core is the media function. And I'll try now to reverse what we've been doing in broadcast over the last decades. We've been focusing on several metadata schemes. That's not a media function. And if you look at the value being produced for a customer, that's probably not too much. He doesn't care if we have a zillion times another metadata system. It's the same for the media transport. I know I have a 2110 sticker here up front, but the user doesn't care if it's NDI, SRT, 2110, whatever it is. It's about this. This is the core of our business, right? And the bigger, we call it the bow tie diagram, by the way. And you know, a small bow tie that's really fancy, but the bigger the bow tie get, you think about clowns. And if it's a real big bow tie, normally the wings do fall off. So it's not supportable anymore. And that's probably the point in time where we are. Sorry if I'm being a little bit straightforward about this. So what can we do? So we have a concept that we call the dynamic media facility. Is it a concept? Probably well. It might be a concept. But there are a few vendors already out there that do things in this space. So it's not just a small group that is thinking about it. There are actually big companies in the industry that are aiming in this direction. Now, as a customer, I do see another problem coming, right? If I go to vendor A, he sells me a stack of compute with their applications on top. They say, oh, but we want to be responsible for our applications. So we need to control the full stack. Vendor Z, the same thing. So from an operational point of view, I've lost again, right? Because now I need to build a stack for all the brands I'm taking in my operations. So that's not the way to go. So I think the call out here is to build some sort of consortium of the willing in order to figure out how we can fix this problem before we have it. And I think it's the right time to talk about this and to bring people together to see what we can do. And I'll make it a little bit more hopefully visual. This means you have a big stack of compute, 2110 is floating in, but there's something proprietary between all the containers running, and on the outside, there's 2110 again. So we need to think about something that runs in a cloud or in a stack that's interoperable between containers, so you as a customer or I as a customer, I can deploy the best media function of the best company that I love in order to make an interoperable system. So, Yevgen, are there any questions?
Not a question, but rather, let's put things in a different perspective. Who remembers the audio over IP times before AES-67? Okay, so you have a PCM-based application and a PCM-based application, but they're not talking to each other, right? So all that frustration. That's kind of it, right? So imagine that you have a stack of, as Willem said, a stack of compute servers, normal servers from Dell or from HP for vendor A, and they deploy their apps or their containers or their functions, however they call them, right? So they have an ingress into the system. The containers talk to each other. The containers do some processing, a DSP vision mix. It doesn't matter, right? And then you have next to it sitting another stack, right? Another stack of servers, another pile of servers. And ironically, it could be the same exact servers from same exact vendor, and they will run another platform that will support their versions of containers, their flavor of containers. And another piece of irony is that both of these containers may be built on a same containerd framework. They could be running a flavor of Docker or a flavor of Kubernetes, built on the same exact principles, but never talking to each other. And the biggest irony would be an SDI cable going between those two racks. Or even better, when a container uses 2110, gets out of the network, then the network passes it back into the same server to talk to another container. Does that make sense? So why cannot I, as a user, support a stack of servers, right? Because because arguably Andrew is not interested in selling me servers. Are you interested in reselling me Dell servers? No. You will be interested to sell me what you do best. What's your secret sauce? What's your gold-plated XLRs, right? It's not the XLR standard. It's the features on top. It's not the it's not a flavor of Kubernetes or an HPE server. It's what they do best: color correction, standards conversion, HDR to SDR processing, media functions. And so if they would run on a platform, arguably a software-based platform that just exposes some sort of a media fabric API, exposes a timing API, exposes a control and UI APIs for the containers to just plug in and have a translation layer, just like ASX7 is a translation layer. ASX7 does not take out the secret sauce of the manufacturer. It just provides a way for them to speak the same language. And if that platform supports containers as a concept, it doesn't matter where this platform runs. And this platform can scale out to other compute resources, like the private cloud, like the public cloud, because containers, as we already discussed, do not care where they run. They're just containers. They have no notion of the underlying infrastructure. So this is the concept that we, it's not a product, right? It's not a solution. It's more a question. Does it make sense? Do you think this is completely delusional? Do you think we are good and IP is our end goal and we never ever need this and the industry is stable and there will be no evolution? So that's something for you to think. And yeah, now any questions?
Maybe just one that I wanted to add is so I said we were together with a few people from the industry, but also manufacturers that deliver GPUs and also the Red Hat guys, for instance. Sorry for calling out the brand, but well, they were there. And they said, we have open source software that you can just use. And yes, we can protect resources. So the manufacturers that build our media functions, they need to trust those vendors as well. We can actually lock and block resources that they shouldn't be afraid about supporting their own application. So that's where we are today. And our guess is that we need to go the IT way. Otherwise, if we're stuck halfway, we don't reap all the benefits of moving to IT.
And we don't have an answer. We don't have a solution. We have just thinking that there must be probably a user request because nothing happens without users requesting that. Yeah, if it's not on RFP, it doesn't exist. But also, there must be a critical mass of vendors who will say, okay, we're going to rethink the way we design our platforms because we don't want to sell you servers. We want to sell you the applications. And just a critical mass of those need to come together. It's not possible for EBU to develop that. It's not possible for SEMTI to develop that just as it is. There needs to be some higher will, and then yeah, let's not get there. Okay, I think our spiel is
Unless there's any question.
yeah. Oh my God. Was it that clear?
We silenced them.
Amazing. I think you mean ANMOS. That's AMW, Advanced Media Workflow Association. Yes-ish. right? So it, frankly, it doesn't matter, because the again, if we think about the abstraction layer is something that hides the complexity, hides the stuff underneath it. And so if the container has a hook that says, okay, this is the media access um, API, behind the scenes there would be something like a Kubernetes operator that will do a translation between, say, a RiverMax API or a Matrox board or a Blackmagic SDK or anything, right? It doesn't matter, because if it's in the cloud, there is no Matrox board. There will be something like a CDI SDK or RiverMax in the cloud, or NDI or Dante API. It doesn't matter. And same goes for the control. It's just an agnostic way of exposing it to the containers so that both containers agree on how they do things. What runs behind the scenes in the larger ecosystem and the larger infrastructure? Should it be Anmos? Should it be Ember Plus? Should it be Katina? It doesn't matter. It shouldn't matter for the Docker. And I would argue that the container itself should not implement Anmos and should not implement